continue our notes here. So previously, we talked about ways to describe a function. We talked about domains and ranges. We talked about positive, negative, 0. And we've talked about increasing, decreasing, constant. Everybody good with that? So this is all prior. We did this these last couple of lessons. What I'm going to talk about today is something called extrema. So there are two types of extrema. There are maximums, but really maximums is bad grammar. The plural for maximum is maxima. And there's minimums, but again, minimums is bad grammar. The plural for minimums is minima. Okay with that? Okay. When we talk about a maximum or minimum, there's two types of these. Yes. We haven't even been using the book. You guys don't even have online book access yet. Oh. Okay. Did we do the calculator? No. Okay. Okay. That's fine. We'll pick up here, and I'm going to show you how to use the calculator to do some of this stuff also, and then we'll continue kind of plowing ahead. Okay? That's fine. So we said that this is the maximum is like the top of the hill, and this is the bottom of a valley. This is any max or min is a local. We say the max is global if it's the highest point. And the minimum is global if it's the lowest point. Not just the lowest among the extrema, but the lowest point, period. Right? So we observe that something like this has a global min here, a local min here, and a local max here. It's not a global max because there are points still higher than it because the arrows are pointing up. Everybody kind of remember doing this part, right? Good. What would you do if you were just given an equation? So suppose you're just given that f of x equals x to the fourth plus 2x to the third minus 4x squared minus 3x plus 1. And you're asked to find, the extrema and the intervals of increasing and decreasing. What would we do here? We're going to use our calculator. In fact, you can do this problem algebraically, but not until you have calculus. So that's a ways off for us. So if you have your graphing calculator with you, please pull that out, and we can follow along. If you don't have your graphing calculator with you, that's okay, because we're recording this lesson. When it comes time to do this part of the homework, my suggestion to you is if you're having trouble using the graphing calculator, You queue up the video from the Power School page and you watch that while you're trying to operate your calculator to do the assignment. Okay? So there will be part of the assignment that you'll need to use your graphing calculator to do. If you don't have your graphing calculator yet, make sure that you pester your mom and dad over the weekend that like, yo, I need my graphing calculator. I actually have to use it to do an assignment now. Okay? Okay, so the first step is we're going to want to turn our graphing calculator on. The on button is located in the lower left-hand corner. Okay, so I'm going to legit explain this as if like no one's ever picked this thing up and used it before, which is fine. Like legit going to be like turn the calculator on is the first step. That's fine. If you want to graph anything on the calculator, which is what we're going to want to do, we're going to want to look at the graph to be able to do this, right? All of the graphing is done using the y equals menu. To access the y equals menu, we have to press the y equals button, which is in the upper left-hand corner of the calculator. So go ahead and press that y equals button now. This is going to open up the y equals menu. Notice at the top where it says plot 1, plot 2, plot 3. Everybody sees that? None of these three should be highlighted. So what do I mean? What would it look like if it was highlighted? It would look like this. If one of those is highlighted, use the up and down and left and right arrows to go to that spot and just press the enter button again to unhighlight it. So none of the plot 1, 2s, or 3s should be highlighted. Everybody's non-highlighted? Good. The next thing I want to do is to make sure that I don't have anything else in my y equals menu that I'm not interested in graphing. So you'll see that I have a problem already entered in here. I want to get rid of that before I start. So I'm going to press the clear button, and that will just wipe everything on that line out. So notice the clear button is directly below the down arrow. Also, if this is not the very first time you've opened the calculator and turned it on, you should probably scroll down and make sure that there's not anything else typed down at the bottom. So I notice that all of my y equals spots are blank, which is good. So I'll just scroll back up to the top now. And I'll say for the record, I find that oftentimes students have like stuff at the bottom of their y equals menu as they put their calculator in their bag without the cover on it and turning it off, and buttons get pressed and like weird stuff happens, and that happens. So if you're having trouble graphing things and getting errors, that's one thing to check for sure. So I noticed that the y equals part is already typed in and built into my calculator. Everybody sees that? So the part that I'm going to worry about typing in is the x's part. So I want to type in x to the fourth, and then plus 2x to the third, minus 4x squared, minus 3x plus 1. So the x button is located one down and one over from the second button, right next to the green alpha button. Yes, so you notice the words in blue above. The words in blue are the commands that you can access when you press second and then that button. The green is you can get that command by pressing alpha in that button. And whatever's written on the button you can press by just pressing the button. So we want just the x, so I'm just going to press that button with the x on it. Now to get an exponent, I'm going to use this caret up button that it's right below the clear button on the right hand side. Notice when I press that, it moves my cursor into the exponent automatically for me. So I can type the number 4. Anybody with an issue there? If I look at my cursor now, you'll notice the design on my cursor has changed. There's a right-hand arrow on it now. What that's telling me is that if I would like to leave the exponent, I need to press the right-hand arrow button. And since I've done typed in x to the fourth, I'm going to press that right arrow button to move out of the exponent and back onto the main line. I'm now going to press the plus key, the number 2, the X button again. I'll press the exponent button again, type the number 3, and then press the right arrow key to get returned back to the main line. Those of you following along, are we doing okay so far? Okay. Now I'm going to type the subtraction key. Make sure that you type subtraction when you mean subtraction. This key here is the negative sign. You cannot use the negative sign and the subtraction symbol interchangeably. So make sure if you mean subtraction, you're typing the subtraction key, and when you mean negative, you're typing the negative key. Everybody's good with that? Okay. I'll type the number 4. I'll type the X again. And I could do the exponent button and the number 2 to get the squared. Or I noticed that 2 down from the alpha is a command that has an x squared on it. If I just press that command, it puts the 2 in there in the exponent automatically. So it saves me like some buttons to press. It's a little bit quicker. And then notice it automatically took me out of the exponent as well. It doesn't matter how you do that, whether you use the exponent button or that squared button. I like doing the squared button because it's like 3 less keys I have to press on the calculator. And then I'll finish it up by typing subtract 3x and then plus 1. Okay with this? Anyone still typing this in? Feel pretty good so far? Next thing I want to do is I want to tell the calculator what I want to be the biggest and smallest x values to graph and the biggest and smallest y values to graph. So I need to pick like what picture I'm going to see. The easiest way to do this is to press the zoom button, which is right here on the top row, and pick the Z standard command. That means zoom standard. So you can scroll down with the up and down arrows and press enter, or you can type the number 6. So you'll see on our graph, or on our display now, is the graph of this function. Everybody's got this same picture I do here that's been following along? No? Okay. Come show me what you have.
It's apparently a whole lot more powerful than it needs to be. So I think I typed it in probably for see if it's zoom up.
Okay. So your zoom is here.
Oh,
so you press F2, and then you can do zoom standard, of course. And now you'll have, wait for it to do it, but it should be basically the same thing.
Oh, okay.
Okay. Thank you. You're welcome. Easy fix. All right. So if I look at this picture, how many maxima do I see? The answer is 1. Where is the maximum? In the middle, right? Everybody agree? Is that local or global? Local. Okay. Well, it's the top of a hill, right? So if I'm walking along the graph, that's like the bottom of a valley, that's the top of a hill, another bottom, and then up forever. There's no top to that. Okay, so the global is the highest point for the maximum. So notice there's a bunch of points on these ends that are higher than that maximum, so it's not global. How many minima do we see? 2. One is here, and the other one is there. Everybody agree with that? This one on the left, is this local or global? Global is correct. And the one on the right then has to be local. Everybody agree with that? What we'd like to be able to do is also determine the actual coordinate of those points. The calculator can help us do this. Okay? So what I'm going to do is I'm going to press the second button. That's in the left, upper left there, in blue. And then I'm going to press the trace command, which is on that top row. This opens up the calculate menu. All of the commands in the calculate menu are things you would do to the graph. So if I say I'm looking for the maximum, which of these commands sounds like the one that I need? The maximum command, command 4. So let's pick that. Yes, of course. Now if I look at my graph, you'll notice at the bottom, the calculator's asking me a question. It says left bound with a question mark. The calculator is going to ask us 3 questions each time we try to use the max or min command. It's going to ask for a left bound, a right bound, and a guess. What we're doing when we answer these questions is we're telling the calculator where it should be searching. So it says where to start my search, that's the left bound. Where to end my search, that's the right bound. And a guess is where to kind of start, like, is there a spot you think it's going to be? The guess doesn't really matter. So if I am looking for the maximum, this is that point here. So anything over here would be a decent left bound. And then anything over here would be a decent right bound. Everybody kind of get the idea of what we mean by left and right bound? You just need to create a boundary of like where to look for this thing. That's all you're doing. It's telling the calculator, start looking here, stop looking here, whatever's the biggest thing in between, tell me. That's all you're doing for the calculator. So you'll notice that on the screen, I have my cursor flashing. It's a little hard to see there, but on your calculator, you should see your cursor flashing. So I'm going to use the left and right arrows to move my cursor so that it is left of that maximum. So it's somewhere over here. You see a little spider-looking thing now flashing? Once I've got it in a good spot, I'll press enter. And again, when we say good spot, like anywhere over here is good. When I press enter, you notice the question changes, and it says right bound. So I'm going to do the same thing. I'm going to press my right arrow keys and move that cursor over to the right side of that maximum. So somewhere over on this piece. Notice my cursor is right here. That looks good. I'll press enter. The last question is a guess. What you pick for your guess really doesn't matter. All it's going to do is make the search go a little bit faster if you pick a good guess. But most of our areas that we're searching are so small anyways, it's really not going to be any appreciably faster. It's going to be like microseconds faster with a good guess. So it's not worth your time bothering to move the cursor along. I just press enter wherever I left off and it works. So notice at the bottom of the calculator it says that maximum is at negative 0.32 and the y is 1.50. So I can just copy that down. That's the point, the location of the maximum. So that point is negative 3.2, 1.5. Note this isn't an interval. This is an x-coordinate and a y-coordinate. This is an ordered pair, not an interval. to be clear. Everybody's okay? Okay. So let's find the global minimum next. So I'm going to press second and trace. Which command do I want this time? 3, the minimum command, because we're looking for the global minimum. Okay. So the global minimum we said was down here. So if I want a left bound, I need to pick something on that part of the global minimum. Everybody good with that idea? So I'm just going to move my cursor over there. So I'm just going to press the left arrow. See my cursor moving along. And I'm just going to keep pressing the left button. There, I see it. That's a fine spot. I'll press enter here. It now changes and asks for a right bound. So I'm going to move my cursor over onto that part of the graph right there. So right bound, pressing the right arrow. There's my little spider right there. I'll press enter. And then for a guess, it doesn't really matter where you pick your guess. I'll just press enter. So it tells me that global minimum is at negative 2.24, comma, negative 9.65. Yeah, I mean, I would tell you how to round. Typically, 2 decimal places would be fine. Yes, McKenna? Of course. When in doubt, you don't do any rounding, and it should be fine. All right. Try to find the last global minimum on your own. So those of you that have been following along with your calculators, try to find that last local minimum. So we have one more of these points to find. So let's find that last point, that last one, the other, the local minimum. You're a weird kid. Kind of rude. Not you. This person criticizing your bathroom trip. All right. So, second, trace, minimum. Move that cursor. That looks good. Press enter. Move that cursor. That looks good. Press enter. Guess anywhere I want. There we go. 1.06, negative 3.03. You rounded the wrong direction. Everybody feel okay on using the calculator? Okay. So if I wanted to write my intervals of increasing, decreasing, and constant, we have everything we need now to be able to do that, right? How many increasing sections do you guys see? 2. I see this one right here that goes from the global minimum to the local maximum. Everybody agree with that? So that's negative 2.24 from the global minimum to negative 0.32 from the local minimum or maximum. Everybody agree? My other increasing part is from the local minimum out forever. So I will go from 1.06 the local minimum to positive infinity. Yes? The one on the left. This one? Well, we go from left to right, so we're downhill, right? So we're always reading the graph from left to right. Yep. Good question. Good to clarify those things. So I see two decreasing sections. I see this one here, and I see this one here. That first decreasing section goes from negative infinity to the global minimum. So negative infinity to negative 2.24. My other decreasing section goes from the local max to the local min. And I don't see any constant parts, do you? We got none of those. We're timing you. Okay. Everybody okay with this idea of using the calculator? So you have to do this in your homework, but again, it's just it's easy. It's the same thing we did yesterday. It's just getting over the hurdle of figuring out how to use your calculator. All right. The next topic is something called end behavior. So this is the fifth descriptor we have for a function. I don't think so, but I have to go back and look at my notes to double check that. Yes, sir.
So for the test, are we going to have to do like all 5 of these, or however many?
I'll have a review before the test, and we'll talk in detail about like what you'd be expected to do or not. To be frank, I haven't written the test yet, so I don't want to tell you what you're going to have to do until I am sure that I know what you're going to have to do. But I will certainly make that clear to you beforehand. Okay? I mean, we're going to take some tests, but not first semester. Yes.
Question about that. Is the second semester, then we do the entire unit review?
Just second semester.
So is this class having enough time?
Huh?
Is this class enough time?
Second semester.
No.
Like I'll have maybe extra credit question on test. All right. So end behavior describes what the arrows on the end of the graph are doing. So let's say that we had this graph. So what would I say that this arrow is doing? Okay, which arrow is it? Well, there's two arrows, right? We have to make it some kind of differentiation. How would you describe this one? Left arrow points up, right? Okay. And then for this one, we would say the, stop talking please, right arrow points down. Everybody agree with that? Okay. End behavior is that easy. The only catch is when we write our end behaviors, we don't like to write it in words. We want to write it in symbols. So it's just going to be a question of understanding the symbols that we use to do this. So when we say left arrow, what we really are saying is x goes to negative infinity. And then when we say points up, we write y goes to positive infinity. Why do we say that? Well, going to the left along the x-axis is the left and right. If we go left, that's towards negative infinity. Up and down is the y-axis. If we're going up, we're going to positive infinity. Does that make sense? So you're talking about this arrow? Yes, we haven't done that one yet. We haven't done that one yet. So this, the right arrow, so over here the x's are getting positive, but the y's are getting negative, correct? So we'll say as x goes to positive infinity, y goes to negative infinity. And that's it. Like, that's as hard as it gets, basically. It's not too bad. So let's look at one more. So this one has 4 arrows, right? So we're going to have 4 descriptions. So let's do them one at a time. Let's start with this one. This is pointing towards what x value? Okay. I agree. And notice how this is almost flat, like the line's almost horizontal. What y value is it pointing towards? 3, right? Everybody okay with that? Let's do this one next. What is the x coordinate that this is going towards? Notice it's almost vertical, right? Looks like -1 to me. But yeah, I mean, like, you're trying to read this from the back of the classroom on something I hand wrote. Like, fair estimate, absolutely. Everybody's fine with that? Okay, and then what is y going towards? We're pointing straight down, so negative infinity. Okay. Let's look at this one. So where is, what x is this pointing towards? -1, good. And the y it's pointing towards is? Positive infinity. Very good. And the last one here, what x are we pointing towards? Positive infinity, very good. And the y we're pointing towards is? 3. Okay. So there is one little issue right now with the way we've written this. And it has to do with when we approach, or as we approach x, we have 2 different y value results. And the reason is when we approach x from the left, we do one thing, and when we approach x from the right, we do another thing. Does everybody see that? So what I'm going to do is we're just going to add a little bit of notation on the 1s to indicate whether we're coming from the left or we're coming from the right. So here, we're starting with the negatives. So I am going to put a negative sign up in that upper right-hand corner. Let me make that a little bit like there. In this one, we're coming from the positives. So I'll put a positive sign up in that upper right-hand corner. Okay. So basically, that means we're going from the left direction, and this is if you come from the right direction. And that's it. This is massively harder than anything I'd ask you to do on a test. That and behavior there. So if you thought that was not a big deal, and behavior in general shouldn't be a big deal. So it's just a question of getting the notation straight. But I find that if we start with words and then show how the notation means the same thing as the words, that usually goes pretty well, rather than starting with the notation first. So we'll stop here.